Welcome everyone to Data Analysis Scholarship course. This is week 5 of Data Analysis Scholarship. My name is Franklin. Today we'll be looking at ANOVA correlation and regression analysis in Microsoft Excel. Let me know if you can hear me, if you can see my screen, much appreciated. Let me know if you can hear me, if you can see my screen. Welcome once more. We are live for tonight's section. Kindly let me know if you can hear me, if you can see my screen. Tonight we will be looking at inferential analysis in the area of ANOVA correlation and regression analysis in Microsoft Excel. How to use regression, correlation, and ANOVA as regards to businesses, as regards to health, as regards to our financial analysis to make informed decision to predict. That is what we will be looking at this night. Let me know if you can hear me, if you can see my screen. That's much appreciated. Shitu, Olaitan, you are welcome. Good to have you. Good to have you. Let me know if you can hear me, if you can see my screen. That much appreciated. One person said I can see your screen. Beautiful. Let me know if I'm audible. If you can see my screen. My name is Franklin. Welcome to week 5 of data analysis course. Welcome to week 5 of data analysis course. Confidence here and confidence. Good to have you. Good to have you. As our tradition is, let's quickly, because this night I don't intend to stay long. I have a very hectic day today, but because we haven't had this section last week and early this week, that's why I decided that whatever happens, I should be able to handle a section tonight. So I will not be staying long. I will not be staying long for tonight's section. Let's go as our tradition demands, as our tradition is. Go to the group, the scholarship group. Tag everybody. Tag as many as you can. Let them know we are live for tonight's section. Let them know that we are live. Tag as many as possible. Tag everyone in the scholarship group. Let them know we are live. Tonight we will be delving into ANOVA. We will be looking at one-way ANOVA analysis. Time will not permit me to get into the two-way ANOVA analysis in Excel, but we will get into correlation, regression, run the analysis, see how we can model our results in order to predict, in order to make some predictions. We are going to be looking at that tonight as in Microsoft Excel. We are going to be doing justice to that. So please, as our tradition is, those of us in the scholarship, as you can hear me, go to the scholarship group, drop in the group that we are live. Drop in the group that we are live. Drop in the group we are live. Tonight's session is going to be an awesome session this night. We are gradually coming to the end of this data analysis course. Next week we will be moving into more advanced stuff. That's week 6. And then we will be doing projects. Next week is something no one should be able to miss. We will be doing projects and then different capstone projects. Running dashboard, health report, business report dashboard, HR dashboard. We are, by God's grace, if time permits us next week, we are going to be doing 3 projects. 1 in business, 2 in HR, 3 in health. Most likely business, HR, and health, or in logistics, depending on what we be doing. All right, Amina, good to have you in the group. Good to have you once again. Good to have us once again. Let's go to the scholarship group. Let everyone know we are live. Also, if you can, which I believe you should, just share this training link to anyone who wishes to learn, to anyone who you know that will be able, that will be willing to learn. I'm always a preacher of acquiring knowledge. I don't hoard knowledge. I don't hoard knowledge. If you know me, I don't hoard knowledge. So be free, share the link to as many as possible that we want to learn. Let's learn together and improve together. All right. If you have done that, kindly let me know. Drop in the chat done. If you have done that, drop in the chat done, so that we proceed. We proceed on what we have tonight. If you have done that, drop in the chat done. If you have gone to the scholarship group, let everyone know in the scholarship group we are live, and tag someone, share the link, and as very important, like this section. Like this section, very important. If you have done that, just drop in the chat done, so that we will proceed to what we have. If you have done that, drop in the chat done. Okay, thank you. You said done. Thank you for that. Good to hear that from us. Let's do that. 1 minute more. We are already 15 minutes gone. 1 minute more before we delve into what we have. One of the things I promise us is to learn data analysis using Excel from scratch to advance. And by God's grace, we are fulfilling that promise. Some of us, we are skeptical. Are we going to learn the full stuff? Are we going to get the full value? Now, I believe that your suspicion, your doubt is being cleared. We don't just teach, we impact. We impart knowledge. We make sure that everyone that passes through us gain premium knowledge. That is one of the things that makes us to be known, that stood out among others. We don't teach. We don't just teach. What we do, we mentor. We make sure that everyone masters what he or she wants to learn. It has always been our mantra that if you are willing to learn, we are always ready to impart. We are always ready to teach. As we all know, we are 100 in this scholarship, but it's few persons that are serious to master these high demanding skills. And in future, you will see the difference. It's not about going for a course. It's not about registering for a course or paying for a course. It's about putting the dedication, the determination to acquire the necessary knowledge embedded, the necessary skills embedded in that course. It's not starting a team, it's finishing it strongly. And I know those of us that have been consistent from day one till now. I know, I've seen our chart, I'm seeing us being consistent. I know them. And those are persons that are going to be getting extra stuff from us. There are things that are in pipeline that we are planning. And most especially those that have been consistent, we receive some considerations as regards to what is about to happen, as regards to what is coming up as in data analysis field. I'm a data scientist, I'm a data analyst with over 7 years experience. I have worked with diverse portfolios industries. I know I have analyzed different data sets. I know what it is. Excel still remains the highly used software, whether analysis in any field. So no one should joke with Excel. And when you see someone who is ready to teach you Excel with high level of in-depth, and to teach you Excel with practicals, don't joke with it. All right, Daniel said done. We are going to proceed right away. We are going to proceed immediately into what we have for tonight. We are going to proceed immediately into what we have. Remember, tonight we are looking at ANOVA, correlation, and the regression. So we are starting tonight with what is ANOVA. Quickly, I'm going to be explaining what ANOVA is. ANOVA stands for analysis of variance. The term ANOVA is an acronym that stands for analysis of variance. That's what ANOVA is. And what do we explain it to be? It's a statistical tool. It's a statistical test that is used to test or to check or to compare if there is significant difference between more than two variables. Between more than two variables. We use it to compare. If it's two variables, we recommend you use the t-test. But once it's more than two, we highly recommend that you use ANOVA. We use it to check if there is any significant difference. If there is any significant difference between the mean of that variable, between the means of that variable. That's what ANOVA is, and that's what we use it. It's a statistical tool, it's a statistical test, it's an analytical test we use to compare if there is any significant difference of more than two above variables. For example, if we want to check if there is any significant difference between the result of student from OAU, student from UI, and student from FUTO, if there is any significant difference in their math result, for example, we are using mathematics as a case study, and we want to check if there is any significant difference between their results of these three schools, or even more than that, 5, 6, 7, 8, as the case may be, we make use of ANOVA. That's on the aspect of ANOVA. Now let's quickly move to types of ANOVA. ANOVA majorly we have two types, but tonight I'm going to make it, we are going to be looking at in distinct aspects. Is two, but there is one with repeated and there is one without. So here we are talking about repeated measure ANOVA. This is one way. Repeated measure we have where is when we are looking at a data set that we have repetition. For example, if you have if you are looking at a result of sales result, you are comparing sales result, how will I put it? You are comparing sales result during rainy season. Sales result during rainy season in month of July. Sales result during rainy season in month of July. The same number of days is what you compared for different branches. That's repeated measure. Is July, and you are checking for the first week. What is the result if there is significant difference? You are looking at it first week, July, week 1, Monday to Sunday, for example, and then you have different results. The one from branch A, the one from branch B, the one from branch C, the one from branch D. You are comparing them, and the result is repeated. Is repeated. That's the one we refer to as repeated measures of ANOVA, and this is referred to as one-way ANOVA. Then we have the one we call one-way ANOVA test, which is not repeated. It's just a random data. So we use it to test one factor or the other. Then quickly we have the one we call two-way ANOVA, which we have with or without replication. Now, if you go further deeper into research analysis, you will be seeing or making use of the two-way ANOVA. Now, what do we use two-way ANOVA to do? We use two-way ANOVA to test. In two-way ANOVA, we are now looking at a dependent variable and independent variable. Now, what's a dependent variable? We have talked about this in our introduction in data analysis. A dependent variable is that variable that depends on another factor and another stuff in order to have an output. So when we look at why in mathematics, y is mostly a dependent variable. So two-way ANOVA, we use two-way ANOVA in analysis to check two independent variable or one dependent variable. Excuse me. We use two-way ANOVA to check two independent variables on one dependent variable. For example, if we want to check the revenue, increase in revenue, what causes the increase in revenue, or we want to check the effect we want to check the effect rainy season and the effect of rainy season and this rainy season effect of seasons. Let me put it that way: season, rainy season and dry season. And then let's say the effect of art, to check what effect does it have on our revenue. The seasons, rainy season, dry season, and art. What does these two factors, rainy season and seasons alone is a factor, and art, running art is another factor. And we want to check these two factors, which are independent variables. Independent variables, we can call them factors. So these two factors, which are independent variables, we want to check the effect they have on our revenue, which is dependent, which is an independent variable. That's two-way ANOVA. We can make two-way ANOVA. We can make use of two-way ANOVA to run that analysis. All right, we move forward to correlation. I'm going to explain them, then we move into the practical section, right into our Excel. What is correlation? Correlation is simple. It's a statistical measure. It is that I check it, that analyze or check the strength and direction of relationship between two or more variables. Correlation is a statistical measure. It's a statistical tool. It's a statistical test that describe or use to describe or use to check or use to find out the strength and direction of the relationship between two or more variables. So correlation is used to analyze in order to find whether there is a significant relationship. Remember, in t-test, we are looking for significant difference. One-way ANOVA, we are looking for significant difference. Two-way ANOVA, we are looking for significant effect or significant impact or significant damage. Then in correlation, we are looking for significant relationship, whether the relationship between two or more variables are significant. And not just significant, we want to know the direction. And then the strength, whether it's something that the relationship, is it a strong relationship? For example, you can't compare the relationship between you and your father or your parents to be the same strength or the same level of relationship between you and your classmate, or between you and your colleague in the office, or between you and your friend. There is relationship, yes, but the strength of that relationship between your parents and you to your colleague or to your classmate or your coursemate is not the same. Is not the same. The strength is not the same. So correlation is used to test, to describe significant relationship between two or more variables, and also to check their strength and the direction, whether it's in the positive direction or in the negative direction. That is what we refer to as correlation. Then we move further into having key points about correlation. We need to understand some key points about correlation. First is the direction. Remember, we said that correlation is to describe the direction and at the same time to check the strength. These are two key areas. These are two key stuffs in correlation. Then the direction, positive correlation. When we talk about positive correlation, is the same in mathematics as what we call direct proportional. In mathematics, we have proportional, direct proportional, indirect, inverse. I think it's direct proportional, inversely proportional, directly proportional, inversely proportional, and that. So in positive correlation, is more of direct proportion in mathematics. What is direct proportion? Increase in one factor will need to increase in the other factor. So when we are looking at whether the relationship is positive, it means that if there is an increase in this variable, it will also lead to an increase in the other variable. That means the relationship is positive. That means the relationship between the two variables or more than two variables, the relationship between them is positive. So when we talk about positive relationship, we are talking about increase in one list to increase in the other. So when you are analyzing and interpreting your result, hence you need to understand and know what the result is saying. What makes you a core analyst is the ability to interpret your result. You can analyze, you can use Excel to get the result, but if you can't interpret the result you have and use it to make informed decision, use it to make informed prediction, use it to write your report, then you are not a full analyst. You are just the ability to analyze and interpret makes you a core analyst. So these are certain things you need to know, understand, that aids you in your interpretation, in your result interpretation and your decision making. All right. Then the negative one is like inversely proportional. That means the increase in one value leads to decrease in the other. So we have a negative correlation where the direction is moving in the negative infinity. In mathematics, we have the number line where we have the positive real numbers and the negative real numbers, or the positive integers and the negative integers, where 0 is the boundary. So the negative correlation is moving in the negative direction, while positive correlation is in the positive direction. And then we have the one we call zero correlation. Now, what does zero correlation implies? Zero correlation implies that there is no relationship. When we have zero, it simply means no relationship. Bear that in mind. It's simple, no relationship between two values. For example, in negative relationship, for example, as a student, research has shown the more you spend time in watching movies, watching TVs can affect your results. So what that simply means that the increase in time of watching movies can lead to decrease in your results. Increase in time of doing irrelevant things can lead to decrease in your productivity. Increase in time of idling away in workplaces doing nothing leads to decrease in your work productivity. There's negative correlation. There is a relationship, but that relationship is negative. Increase in your productivity will surely means that you have little or no time idling away. So that is negative correlation. But for example, when we talk about no correlation, let me think of one example to give now. No correlation. For example, with the size of your shoe, let me use even this one. The size of your shoe does not have any relationship to your exam, to your score, to your result. The size of your shoe does not have any relationship to your productivity. The size of your shoe does not have any relationship to your result. So in that, there is no relationship at all. There is no relationship at all. There is no relationship. So these are key aspects in correlation as regards to direction. Then we proceed to the other one, which is still on the key point. We have strength. We have strength. Now, what are strengths? Strength is what you now need to know. What is the strength of this relationship? Relationship exists. We have significant relationship, either positive or negative. Now, since we have this relationship, we can now test, we can now check what is the level of this relationship. And that is where we need to understand the Pearson correlation coefficient, the Pearson correlation, the Spearman, the Kendall. But in strength, we have that correlation strength values ranges between 0 and 1. Let me explain what I mean between 0 and 1. But here we have minus 1 to 1. Why minus 1? Minus 1 is not really a magnitude. It's not really a value. In mathematics, that's what we call magnitude. When you put any negative number in a magnitude, it becomes positive. So in this strength, the negative there is more like the direction. It's more like the direction. We are considering both the negative correlation and the positive correlation. Not that minus 1 means in kind of value. No. So what that is that the value, the strength of correlation ranges between 0 and 1. Remember, analysis, statistics is a mathematics of 0 and 1. We are in between this. We are in between this 0 and 1. The extreme is the perfect, the 0 is non-existent. We are in between. So the range between 0 and 1 is what we use to determine the strength of the correlation. And within this place, if we have plus 1, that's a perfect positive relationship. Perfect. And is strong, very strong, very, very strong, perfect. Then we have, if we have negative 1, that's perfect negative relationship. Remember, I said the negative sign there is to show us the direction of relationship is in the negative direction. Then 0 means no relationship at all. Now let's proceed further to now see the table. How we grade this relationship, how we grade the strength of the correlation. R value, if R value is simply your correlation coefficient, that's your R value, your correlation coefficient. If you make use of Pearson correlation, R value becomes your Pearson correlation coefficient. Now, if it's between 0.9 to 1, that's very strong. If it's between 0.7 to 0.89, that is strong. If it's between 0.5 to 0.69, moderate. 0.3 to 0.49, weak. If it's between 0.00 to 0.29, very weak or not. If it's 0, that's not. No, there is no strength at all. In fact, there is no even relationship. So with this, when you analyze your result, when you analyze your data set rather, and you have your result, with the result, you can now check what is my correlation coefficient value. From the correlation coefficient value, you can now determine whether the relationship that exists, if it's a very strong negative relationship, or very strong positive relationship, or strong positive relationship. You need to know the level or the strength of the relationship. If there is relationship, but if there is no relationship, then there is no need of you taking the strength of the relationship in the first place. All right. Now, having established that, let's quickly proceed and try to be fast. Groups of correlation. I grouped correlation into 2. I grouped correlation into 2. We have the one we call simple correlation. Now, what is simple correlation is when you are testing relationship between two values, between two variables rather. When you are testing relationship between two variables, that is simple correlation. Then we have multiple correlation when you are testing relationship between more than two variables. That becomes multiple correlation. If you are joining us, this is Data Analysis Scholarship course. please, if you are with us, you hit the like button. That helps this last section, and it helps the channel as well. If you haven't liked the session, endeavor you like the session, and even if you are watching it after now, also ensure to hit the like button. That goes a long way keeping the channel healthy, and also feel free to share anytime, any day. All right, now that is the groups of correlation: simple correlation and multiple correlation. That's the two groups I put correlation into. Remember, simple correlation is when you are checking relationship between two variables. Multiple is more than two variables. That's what we have. All right, we proceed to the next types of correlation. Types of correlation. We have the one we call the Pearson correlation. This measures linear relationship. When we are talking about linear is stuff on a straight line. Linear relationship. If it's increasing, it's on a linear trend. If it's decreasing, it's on that trend. So linear relationship, once your data is normally distributed, once your data is normally distributed and the parametric sample, then you know you have to make use of Pearson correlation coefficient. And most times, if your data is in ratios and intervals, Pearson correlation coefficient is used. We use Pearson correlation coefficient. So Pearson correlation makes use of data. We use Pearson correlation coefficient when your data set is normally distributed and the data values or the data points are intervals, ratios, or integers. So that's on the Pearson correlation. Then the next one is what we call Spearman correlation or Spearman ranks. We use it when we rank our data points. When your data point is ranked, you make use of Spearman. I will give us, if time permits me this night, I will give us an example of what we mean by the Pearson, and then when to use the Spearman rank correlation coefficients. All right, then the last one is Kendall. We usually use Kendall if it's similar to Spearman. We are using it in ranks. And please also, that reminds me, both of them we use both of them when the data set is not normally distributed. Pearson correlation coefficient, remember I said we use it when the data set is normally distributed. These are some statistical terms. You don't bother yourself much on that. Maybe later you can, if you have time, read up on them, but they are easy to understand. Normally distributed and not normally distributed. So for Spearman and Kendall, we use it when the data set is not normally distributed. Is not normally distributed for non-parametric samples. For non-parametric samples, the data set is not normally distributed. All right, but this one is more for small data set. We recommend this if it's small data set. This one, the Spearman is for large data set. Spearman, Pearson correlation, both large and small, we can use it provided the data set is normally distributed. All right. Oh, Tochukwu, good to have you. Timothy, good to have you. All right. Okay. Now that's the three types of correlation. There are other ones, but these are the major ones. These are the major ones. Okay. We proceed to regression analysis or regression. I'm rushing it so that we can get into Excel and do some analysis and do some interpretations, and we end tonight. Tonight I'm not really going to stay long. I'm not really going to stay long for tonight's section. I had a very, 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 very hectic day today. But I said to myself, we must definitely have this section tonight, because very soon data analysis scholarship cohort 2 will commence. So I need to release myself from cohort 1 so as to be ready to impact cohort 2 as well, while we will be working on our project and portfolios. Those of us who finishes your project and submit your project assignment, and you have concluded this course by submitting your project assignments, by doing your projects, and then to a conclusion or to a completion, we will be having a section that will be a closed door section on how to craft out data analysis CV. As a data analyst, how you can package your CV. This is only to those who complete this course. I'm not going to teach data analysis after then. Those that didn't complete it will come and learn how to prepare a data analysis CV and cover letter, package themselves in the workplace, in the labor market, and how to go about in securing those opportunities as regards to data analysis. No, it will strictly be those who finish. Those are reward for finishing strong. Those are reward those that finishes strong gets. So at the end, those of us that finishes, we will have that session. It's a closed door. It's not something I will share on YouTube. That training will be a closed door session on Zoom section. Zoom session link will be sent to only those who have finished this course. We will be together, learn it. You ask your question, we design your CV, we craft your CV and target it to data analysis jobs, to data analysis to data analysis related jobs, and then share nuggets on how you can go about to get opportunities as regards to this particular skill. Is already prepared. There are certain things lined up to those of us who are finishing strong. Like I said, I know us from day one to now that have been consistent in submitting your assignments, in being attentive to class, and what have you. I know us. It's not all that started we finish. That's why there is a saying that says many are called, but few are chosen. All right. Now, what's regression? What is regression? Regression simply is a statistical tool. Regression simply is a statistical tool. It's a statistical method that used to examine relationship, not just relationship, to check influence, impact, to check significant impact, significant effect, in order to make some predictions, in order to predict, in order to check variable changes. That is regression. Regression is a tool we use to test both significant relationship and to make predictions as regards to our data sets. In fact, regression is one of the statistical tools we use to make powerful predictions. What data forecasting in Excel can't handle, regression can handle it. In data forecasting, we can forecast between two variables, the dependent and independent. Now, what happens when they are more than one? When the independent variable is one, the dependent variable is one. What happens when the independent variables, the factors, what happens when they are more than one? That is where regression model comes. We call it data analysis, we call it prediction model or regression model. You model your equation, you model your prediction in order to make informed decisions and make some informed predictions. All right. Now that's what we explain regression analysis to be. It helps us to understand how strongly variables are related, that's in relationship, and then how one variable changes when others changes, that's in variable changes, and then very important to make predictions about future, to forecast, to make predictions. That is what regression helps us to understand or helps us to achieve as data analysts. All right, we progress or we proceed to types of regression. Regression, there are different types of regression, but tonight I'm going to be focusing in two major types. If time permits me, I might open our eyes to that other one, but that one mostly is okay. Sometimes we make use of it. I will explain that. Three of them mostly used, but other ones are for higher research models, which we might not need. When we need it, we will get access to the training at that time. All right. Now the first one under types of regression is what we call simple linear regression. Simple linear regression is when we are considering one dependent variable and one independent variable. That's simple linear regression. In a simple term, when we use simple linear regression, is when we are considering one independent variable to one dependent variable. One independent variable to one dependent variable. Remember I said independent variable, we can call it factors. We can call it predictors as well. So when you are considering one dependent and one independent, that is simple linear regression. And when we talk about simple linear, when we're talking about linear, we are talking about equation of a straight line. The regression model for simple linear regression is the same as equation of a straight line. The simple linear regression model, the model for it is the same as equation of a straight line. And what does equation of a straight line say? Let me use something. Now, equation of a straight line, we can call it to be y. Equation of a straight line can be y equals to ms plus c. ms plus c. Don't mind my sketching. This is equation of a straight line. Y equals to ms plus c. Y, which is the dependent variable. Y here, y is the dependent variable. don't mind my y here is the dependent variable. You understand what I'm saying? Then the s here is the independent variable. Y x here, in mathematics we call it the slope. We call it x rather, not s rather, not s, the m we call it the slope. And this in regression we call it the coefficients. We call it the coefficient, and will show us in the result. Then c is the intercept or the constant in the result. So when we look at this, that's what we refer to as simple linear. That's what we refer to as simple linear. All right, the next one is multiple linear regression. Now, multiple linear regression is one dependent against more than one independent. One dependent against more than one factors. And in other words, those factors that affect the result of the dependent variable. If there are more than one, that is multiple linear regression. Multiple linear regression. If there are more than one factors, more than one predictors, more than one values that affect the dependent variable, then we are talking about multiple linear. We're talking about multiple linear regression. And multiple linear regression, we can, the equation is y equals to mx1 plus ms2 plus dot 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 plus msn, then plus c. Now what we are saying is that for multiple linear, the regression model, the regression model, what is the linear equation or linear model? The highest power of the unknowns is 1. That's what we refer to as linear. Whether in mathematics, in analysis, and in linear, the highest power of the unknown here is x and y. The highest power of the unknown is 1. So we refer to this as multiple linear regression is because the factors here are x1, x2, up to xn. If they are more than 1, that's what makes it multiple linear. So we have more than 1 factors, x1, x2, up to xn, depending on the number of factors available. So this becomes the multiple linear regression model. What we have here becomes the multiple linear regression model. Let's bear that in mind. All right. Now, having established that, we proceed to the next one, which we call logistic regression. Logistic regression is where we have that the dependent variable. Now, y, the y here is now in category. Let's say y have the y, which is the dependent variable, is in category, let's say, of yes or no. That is when we are talking about the logistic regression. The logistic regression, when we use logistic regression when the dependent variable is now in category, is now categorized, yes or no, or any category that it falls in, the dependent variable falls in yes or no, which is 0 and 1. Please note that it is, if the category is in 0 and 1, which one can be yes, the other can be no, one can be true, the other can be false. Please note that as well. That's when we make use of logistic regression. But tonight, based on, we are going to be focusing on simple and linear regression in Microsoft Excel. Then there are other advanced types of regression. We have polynomial, where the power is more than 1. We have the ridge, we have the lasso. Polynomial, where the power of the unknown is more than 1. We have the ridge, we have the lasso. These are types of regression. Now, why do we use regression analysis? One is to explain relationship between variables. We have established that 2, to predict outcomes, sales forecast, risk assessment, and all that. Then we have to control confounding values of variables in research, and then to optimize decision making. Very important. This is one core reason. This is one core use of regression analysis, to optimize our decision making using the regression model. Using the regression model for marketing budget allocation and the sales target and all that, to optimize our decision making. That is why we make use of regression analysis. All right, and that is where we will stop based on the theoretical part. Let's quickly head over to Excel in order to do some practical analysis. Let's quickly head over to that in order to do some stuff. All right. Okay. Now I'm going to, this is a data set I generated for this particular okay, and okay, this just give me a minute. Okay. This something I'm looking for. I can't zoom in. I don't know why. Okay, let me. All right, now I have this data set for one-way ANOVA. Remember, one-way ANOVA is to test if there is any significant difference. This sales. Now get to understand this data set. I call it sales analysis. Now this is what we have, sales ID, and then this is the sales we have when there is no discount or no social media ads or any loyalty we give out. So here is the sales we have. Here is the sales we also have when we give discounts or promo. We did promo, sales promo, we give discounts, and these sales we have when we run social media ads, we generated these sales, and then when we do some loyalties based on some customers and that, we have this sales result. So here is a record of our data set. Here is a record of our data set. I guess it's okay now. Someone said I should zoom a bit. I guess that is okay now. We are okay. I think the is okay. Let me know. Let me know. Dennis, is it okay? Is that okay? Let me know. Let me know. Dennis, is it okay? Is it okay? Or someone else, please, if it's okay, let me know. Let me know. Let me know. Drop in. Please let me know if you can hear me now. I think we are back. I think we are back. Let me know. Confirm if you can hear me. I want us to move fast. I want us to move with speed of light. Confirm if you can hear me. I think we are back now. Let someone please confirm if you can hear me, if you can see my screen. Let's confirm if it's okay from your end so that we proceed. All right, thank you, Joseph. Can someone else confirm also? Let me get one more confirmation if it's okay from your end. Now from my end is, I think I'm okay. It's okay from my end, but I need to be sure that we're on the same page. If you're with me here, you can drop a chat. If it's okay from your end, let me know. Also, feel free to drop your questions. If you have any question, feel free to drop it. Okay, yes, Benedicta, beautiful. Yes, he's back. Daniel, I can hear you, sir. Beautiful. Okay, now to analyze this data set to check whether there is any difference. If there is significant difference in sales, when there is no discount or no promotion, when there is no ad, I guess when there is discount, social ads, and then loyalty. To check this, we will need to rearrange our data set. We need to rearrange our data set. And to do that, I'm going to do something here. I'm going to do something here. Let me Control C. Let me come here and paste Control V. And home here. Let me merge it so that I have this. And let me copy this. Control C. And then let me paste here Control V, and let me remove any image. Let me drag this one here. Let me drag this one here. And permit me, let me just remove that. These ones okay, now I'm going to pull out this. I'm going to pull out this. Pull out this as well. Pull out the sales. And do this one as well. Control C. And then come here to paste. Control V. All right. Now what did I do? I have made this data set to be under these headings. I just remove the ID. I don't really need the ID. I don't really need the ID. So what I'm working on is this. I want to check if there is any significant difference between these two variables. None, discount, social ad, loyalty. Now we are checking. Let's say the manager asks you are a business analyst, a data analyst in a company. They have this result. They say, okay, run analysis, check if there is any significant difference between these results we have here. Quickly, you make use of one-way ANOVA. You can use SPSS, you can use R, you can use Python, you can use Excel as well. There are different statistical tools. There are different statistical softwares that can run this analysis for us. Okay, now to do one-way ANOVA, we go to data. I have shown you how to activate your data analysis ToolPak. So you go to data, click on data analysis. Now on data analysis, you click on ANOVA, single factor. Now single factor is simple, one-way ANOVA, single factor. Now under single factor, you click OK. Now once you click OK inside this input range, now under the input range, you come over to this place, highlight everything down to this point. Once you highlight it, if your data set is in columns, which is what our data arrangement is, our data set are arranged in columns under column M, N, O, and P. That's what our data set is arranged on. If it's arranged in rows, that means none will be, let's say, row 7, discount row 8, social ad row 9, and loyalty row 10. If it's in that way and the results are this side, this horizontal, then you select rows. That is on that. Then remember, when we are highlighting, we highlighted or we selected both the column headers. We both the column headers. Here the column header for this is none. This one is discount, social ad, and loyalty. So we click on this. We click on label, and then our significant threshold, we are making it to be 0.05. Our significant threshold, level of significance. Our level of significance, standard level of significance, 0.05. If it's not, depending on your research, depending on what you are working on, depending on the level of accuracy you are looking for, you can reduce, increase as the case may be. All right. Now that is on that. Now for today, we will be working on new sheet. The last time we used output range. Now let's at least make use of the new worksheet. That means it will create another worksheet for me. Now here in that worksheet, I want to call it one-way result, one-way ANOVA result. So I can name it one-way ANOVA results. One-way ANOVA result. So what that implies is that, like this name I gave here, immediately it will also have that name. I don't need to come and rename it again. So once everything is okay, I click OK. Now you see what we have here. You see is now one-way ANOVA result. The name is there. This is our result. This is our result. Let me expand them so that we get full stuff on it. Now let's explain this result. Let's explain this result together. Let's interpret this result together. Someone is saying it's not clear. Please, if it's not clear, increase the quality of your video. Increase the quality on YouTube. Maybe you are viewing below the quality threshold. So please, if it's not clear, if it's blurry, just increase the quality of your video. I have zoomed in to, I think, let me make it 140 so that it will be more visible. Okay, now let's interpret our result. Let's interpret our result. The result we have here. The result we have here. Now here, we have here that none have a data point. This is count. You know in Microsoft Excel, the function called count, which count the number of data points. In data analysis, the number of data points. Here, if we check, if you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is 15. If you count it on your own, is 15. Do to time. Let's not waste time. It counts it is 15. All of them are 15, 15. So it shows us the number of data points. And when we talk about sum here is very simple. the sum there is the sum of the total value. If you sum up everything here under none, it gives you this value, and then the same to this. Average means mean. Average is the same as mean, and variance is the square, the formula for calculating variance. I think the square root also. I can't remember. But the variance here is used to check how spread apart the data points are. Now, under the ANOVA, we have this. Here is where this is the ANOVA result. Here is more like the descriptive statistics results. I'm going to be showing us how to interpret data. I'm going to be showing us how to interpret your data set. So here is your descriptive statistics result. What you are seeing here are descriptive statistics. Now this is your ANOVA result. XS means sum of squares. XX means sum of squares. That's what XS means. Between groups. Sum of squares between groups. Sum of squares between groups. That's what SS means. Sum of squares between groups. This one within groups. The degree of freedom, that's DF. What it means, this one between groups is degree of freedom. And to get your degree of freedom is just simple. Degree of freedom between groups is, these are four, we have four groups. The degree of freedom is gotten by total number of groups minus 1. That's how to calculate your degree of freedom. Is equals to the total number of groups minus 1. If it's between groups, please note that. If it's between groups, that's how to get it. But in analysis, you shouldn't be caring. You don't care how you get this. Excel does it for you. I'm just bringing that. I'm just trying to make some of this, explain some of this stuff. Due to time, I will not even be going fully into talking about them. Please, can someone let me know if you can hear? Please, can we hear me now? Please. It seems my network is. Let me know. Drop in the chat if you can hear me, if we are on now. Please let me know if you can hear me now. If you are on, I need to be fast, please. I need to be fast. Can someone drop in the chat if we are on now, if you can hear me? All right, let's Permit me, I might be moving with speed of light. Permit me, please. I might be moving with speed of light. Now, the degree of freedom I said between groups is just total number of group minus 1. Within groups is the total sum. If you sum up the number of data points, if you sum up the number of data points minus 4, that's minus the number of group, minus the number of group. If you sum up the number of data points minus the number of groups, that's when you are talking about your degree of freedom, within groups. This one between groups is total number of group minus 1. Within group is the total sum of data points. That's this is this plus this plus this plus this is 60 minus 4. The number of groups, you get 56. That's what degree of freedom is. This total is the sum of this and this gives you this. The sum of this and this gives you this. Mean square, this mx means mean square. They are the time where we focus on this result is our p-value. Our focus on this result is our p-value, which shows that there is significant difference. Time will not permit me to ask us to respond in the chat what we think it is. Time will not permit me to ask us that. Please. Time will not permit me. Okay, now to interpret this data, the way you start is first for your data interpretation, you can please give me a minute. Okay, for your data interpretation, first you can start by saying this test. For example, you can start for interpretation, this test was done using one-way ANOVA. You let us know the tool you use. This test was done using one-way ANOVA. Now, full stop. The next is to talk about your descriptive statistics. Your descriptive statistics result. Descriptive statistics.